In the previous video, we assessed the data that are available about your pumps and fans. We'll now look at the second step of the structured approach to estimating energy savings: how to use the data you have to establish an accurate and reliable energy consumption baseline. This will help ensure you can compare any energy savings estimates against total energy consumption and ensure you're getting reasonable results. To establish a baseline of annual energy consumption for your pump or fan, you'll need to do the following. First, determine the power draw of your pump or fan at different loads. Second, understand the equipment's operating profile to determine how much time the pump or fan operates at different loads. Finally, combine the results of the first two steps to determine the total baseline energy consumption of your pump or fan. In addition to the total annual energy consumption, it's good to know the requirements of your pump or fan, specifically the discharge pressure and average flow. These parameters are important as they'll allow you to compare operating conditions before and after your energy-saving project. However, if these data are not available, the first step in establishing a reliable energy baseline is to determine how much power your pump or fan draws at different loads. For the most accurate data, use a power meter that continuously records power draw over time. Alternatively, you can use an ammeter to measure amps and then calculate power. Although voltage and power factor can be assumed, it's important to remember that the power factor can change with operating load, so an assumed power factor may not be accurate if your motor operates over a wide range of loads, particularly below 60% load. If you don't have amperage measurements but can measure motor speed using a tachometer or other device, you can use the slip method to estimate the motor load. However, this method is generally less accurate. Finally, if all you have are the nameplate data, you can calculate the motor power by estimating the load factor. The load factor refers to the load on a motor as a percentage of full load. When using this method, remember that most equipment is over-designed and will have a load factor lower than 1. This method is the simplest, but will provide the least accurate results. If you use estimates or assumptions to calculate power, you can use the system curves and pump or fan curves to check the reasonableness of these calculations. This step is important because it can help confirm the validity of your power estimates. If the curves are not available, you can use pump or fan equations to calculate the mechanical power from pressure and flow measurements. Alternatively, if the pump or fan has a variable frequency drive, or VFD, you can use affinity or fan laws to determine the motor load. When using this method, consider the efficiency of the motor and VFD, and do not use this method for systems with high static pressure. To accurately estimate your baseline energy consumption, you need to multiply the power draw by the runtime, as outlined in this equation. While it may be difficult to obtain full measurements for power, flow, and pressure, you should be able to obtain a continuous trend of operating data that provides a proxy for your equipment's mode of operation. Ideally, try to get data from a period of at least 12 months. The duty cycle indicates how much time the pump or fan is actually running and how much time it is off. Many projects overestimate energy savings by assuming the motor is always running. If you don't have equipment duty cycles data, you can manually time the system's operating modes. Make sure you capture a representative sample of all cycles. You may want to consider how your pump or fan operates to see if you need to invest in some metering equipment to improve the accuracy of your estimates. Does it run at a constant operating point, or does it have different operating modes? Does it modulate significantly to meet system demands? Selecting the correct calculation method for your operation is essential to obtaining accurate data. Finally, consider combining these approaches to validate your calculations and increase your confidence in the results. For example, if you have a power calculation using amps, the pump or fan curves, a pressure measurement for the discharge, You could convert the electrical power to mechanical power, or BHP, then plot the pump or fan BHP on a pump or fan curve. Then, check that the curve matches the pressure measurement. If the values don't match, you can investigate and correct possible causes. Once a reasonable baseline has been established, the next step is to determine the savings mechanism of your energy savings opportunity to understand how these changes might affect your baseline energy consumption. In the next video, we'll look at the different savings mechanisms available for pumps and fans.